Good afternoon, everyone. How we doing? We good?
Yep.
Fantastic. Can you all hear us okay? Amazing. Right. Thank you so much for coming. My name's Joe. I'm a Principal Solution Architect here at Matillion, and I'm joined by our Chief of Data and AI, Julian. Julian, say hello quick.
Yep, hi there. Glad to be with you lot. I'm substituting for my friend Cyril here, who's sadly suffered from too much presentation and he can't talk anymore. So there may be some improvisation going on here. But thank you for joining us in the theatre. To kick us off, we're going to need a volunteer. Now, Joe, what was it you need from a volunteer?
Just a volunteer from any data engineer today with the name of the organization that they work for and a really difficult challenge that they're currently facing in their day-to-day roles. And we're going to create a customized demo for that volunteer. So anyone a hand raise?
Yeah. No Matillioners, or at least nobody wearing a T-shirt, because that'd be too obvious. But
any hand raisers, or I will start picking on people in the front row.
Yeah.
So if you're in the front row and you'd like to volunteer now, would be your chance.
No.
Yes, sir. How are we doing? I'm grand. What's your name, mate? Naya. Fantastic. Who'd you work for now? Squawkle. Oh, okay. Fantastic. Okay. So I'm going to just kick off a automated process that I've got here in the back end. Am I spelling that correctly? Is that spelled correctly? Yeah? Perfect.
Yes, it is.
Amazing. And we'll come back to this in just a moment in time. It takes about 90 seconds to run. So whilst we wait for that one to run, Julian, why don't you take us away with a little bit about the future of data engineering?
We're on to the first slide. Okay, so obviously lots of organizations want to do AI. You're probably hearing it from your CEOs and your CIOs. Everybody wants to do things. There's a lot of exciting potential out there. Most of the headaches aren't technical these days. People-based, process-based, getting the data to the right place. The bottleneck is, unsurprisingly, landing with us in the data space. Every AI project in the world is either generating a ton of data, needs a ton of data, needs a ton of data processing. Only problem is data engineering teams are massively overloaded already. If we can do the next slide. It's a huge demand, can't keep up. Huge number of use cases. If you're lucky, you can get the heads to kind of keep on top of it, but generally you're not getting them. I don't know a data engineering team in the world that's on top of its own existing backlog, leaving aside the lovely, fancy, shining AI projects and similar use cases. People want to explore personalization. They want to explore RAG. Chatbots are becoming quite a common thing now. Of course, you're supposed to be driving revenue growth because we're in a tough economy, to say the least. And the cost of inaction is not just that you become the person blamed for not the initiative not working, because they've got to find somebody to point their finger out if it doesn't work, and that's going to be the data team usually. Plus, your team get burnt out, feel very unappreciated, unloved, and generally underwhelmed. So if we move on to the next slide. Even today, data engineering on the human scale is overloaded. You think of all the sources on the right-hand side, huge number, ever-growing number of providers, apps, suppliers, cloud databases. And that's just to feed the traditional needs of BI, data science data, operational analytics. Possibly you've got consultants in demanding data. Your teams already can't scale. The future is only going to get worse. More and more and more sources, increased number of use cases. You're not just providing data for humans, you're providing data for human to agent communication or agent to agent communication. It's going to generate more and more. How can the team scale? We can't keep adding people at it. We've got to provide assistance to make that team more productive and allow them to grow. Our little logos here represent Maia, which we'll be demoing in a second. Maia is Matillion's Agentic data assistant. It provides a natural language interface to chat to our software. Our software is a platform for moving data around, transforming it, getting it to the right shape, getting it to the right place. What we found is that working in a constrained environment, we're able to get great results from a large language model. Matillion's only got a defined number of components. We've only got 200-300 components. It's very easy to teach an LLM to use a small subset of those. It's also very easy to get them to get it right when you give them validation messages, feedback, and similar. And we'll talk a little bit more about what's going on under the hood later. But really, We have seen cases from our customers already adopting this product. Bear in mind, we're only live with this 9 weeks ago, June. We've seen examples where the team have gone on site. I don't know if it was Joe or one of the others, was able to put something together as a data pipeline in an hour from the same instructions that had taken a data engineer 40 hours the previous week, 40. So we move on. Well, little bit of like architecture, short version. Matillion is a control plane layer, sits on top of your cloud data warehouse, pushes down the SQL or the Python as instructions to drive that. So we get the compute and the storage from our partners, like our compute storage partner of the year, Snowflake. Our agent is getting its instructions from Maia in terms of what it should be doing. It can be a mix of human and Maia interaction. So you can chat to Maia in a chat window, say, I want to build this data pipeline, and then maybe it's not quite what you wanted or had in mind. You could edit that manually, or equally, you could go the other way. You can take the pipelines that you built hands-on yourself previously and then say to Maia, hey, can you update these? I want to update the variable name to this new name now, or we'll do that across all my pipelines.
Just to add in on this slide, Julian, this is deployed inside of a Snowflake container, this agent, but we also run inside of AWS Elastic Container Services or Azure Container Apps as well. So it's all the data plane is always inside of your cloud infrastructure. So therefore, all of that data movement is taking place in that securely governed environment that you own, whereas the build and design time is taking place inside of the Data Productivity Cloud, our SaaS platform that's trusted by design, SOC 2 and ISO 27001 compliant, and we'll come on to that in just a second.
We'll move on. Yep. So how does the Agentic framework work? So when we say Agentic system, we generally mean this is a series of AI agents. Full cards on the table. The models using these aren't fine-tuned proprietary pieces. We're using the best of in-class providers we can get. At the moment, there's a lot of Anthropic Claude models. That will probably change and evolve over time as better models come and go. A lot of what my team does is just evaluating what's the best model for each task at any one time. The data engineering agent has been equipped with tools that let it work like a Matillion user. So it can do the equivalent of look in a drop-down and see what the available menu options are. It can sample the data in the table just the same way a human would, assuming you give it permission. It can look at the validation errors and try and correct its work based on those. There are various other tools. It can connect into the Git repos, so it can do your pushes. It can provide commit messages if you want. Likewise, it can push into what's going on with the analytics of what's the performance of previous pipelines, do root cause analysis of error messages and the like. Carry on. Next one.
Yeah, I'm ready to go for the demo, Julian.
All right. Okay. Well, let's bin this off.
You want to come back?
We'll do this one. We'll do this one. So this is kind of the comparison of what's going on. We have a data pipeline language, which is just a markdown format, sorry, YAML format that configures our components. Maia edits that, and then our interface will render that as the components you see on that kind of pipeline. So that's showing some table inputs, a join, some filters and the like. You could very easily get an LLM to write a ton of SQL. The problem is, if you're in a hurry, or either you don't have the technical knowledge, or you're in a hurry, then you're not going to have time to read and understand that on the one on the right. However, on the left, we break it down because we're a low-code graphical platform at heart. We break it down into little components, individual components, that you can sample each one of, and they're very easy to inspect. It's very easy to look at a filter component. It's got like 2 parameters. What field am I filtering on? What condition? And is it an and or an or? So it's very easy to debug and check that Maia has built the thing you wanted it to build. Okay, cool. Let's cut over to you.
Thank you so much. We're going to just go back to that branch you saw me create at the start. Nyan, for those of you who are interested in how the sausage is made, we're using GitHub Actions and some Cortex under the hood to generate some fictitious data sets for Nyan. Thank you very much for volunteering, Nyan. Have you got a mic on there, good sir? Excellent. So Nyan, we're here inside of the Data Productivity Cloud. We're going to put Maia, our agentic data team, to work. Can you summarize for the room here a challenge that you run into? Is it building star schemas, building data vaults, connecting to sources?
So a lot of our source systems are actually just spreadsheets. So
Okay.
A lot of static spreadsheets all over the place.
Cool. And when you're doing that data modeling, are you doing that in a facts and dimensions way, or
Yeah, very simplistic, trying to connect all the spreadsheets together, build some sort of data model.
Fantastic. So what we did is we created some fictitious data for you. So projects, consultant assignments, revenue tracking. So this has just been stored inside of Snowflake. The data's already there. What we're actually going to do is we're going to put Maia to work. I'm going to tell Maia, read the data landscape markdown file. That's the instructions of those tables that we just saw.
Yeah.
Build me a sophisticated star schema model.
Fortunately, Maia can spell better than Joe can.
Ingest from, I don't have any spreadsheets, but I do have SQL Server or Postgres. Any
Postgres?
Postgres, right. Ingest from our Postgres this data. Read source databases. And then fully model the output. Document, test, and create a predictive model for my next quarter's revenue. So we're going to give Maia, I mean, it's a bit of a lengthy prompt, but you can give it even lengthier prompts if you like. We're going to give Maia that whole task. Now, Nyan, how long would that take you to build an ingestion engine, a star schema model, join all of that together, document your work, test it? How long will that take you today, sir?
Ages.
Ages. I had a quarter yesterday. Anyone want to say longer than a quarter? Higher or longer? Higher or lower? Higher. Higher than a quarter. There we go. I'll say higher than a quarter. Okay, so we're going to see Maia perform that today here in about 10 minutes.
Yeah.
Now, as it goes through, Maia is actually having these thoughts. So we'll expand on the first one. The user wants me to read these markdown files. So hands up if everyone's aware of context and markdown files, or is that some people? So to most people, it's quite new, quite a new concept. So these are the instructions that you can create to onboard Maia into your environment.
Yeah.
So you can feed it your PDFs, your Confluence. You can point it to an external Git repository that has your JSON data model or XML code in.
Yeah. It's no different if you had a new member of your team joining, right? You had a new junior data engineer. You need to give them some docs to get started. You need to have them sit down with maybe a senior to walk them through the landscape, and probably come out with maybe a Word doc with a few bullets they've captured from listening to that person.
So these context files you populate with your information that is specific to how you design pipelines and how you build pipelines in your organization. Maia then adheres to and builds pipelines as a team member inside of your org. So now we could see the data landscape files that Maia's got access to. That is Maia then finding these data sources. So it's found that Postgres that we're hosting on an RDS, and I've actually got a file here with some source databases in as well. So it's using these reference points. So you can then start to add in all of these additional data sources into the knowledge base that Maia can leverage. And then as you go through, Maia can already build that data ingestion engine and it's loading my project's data from Postgres. These are those components that Julian was referencing earlier that we can drag and drop onto the canvas. We've got over 130 connectors out of the box to all of your enterprise connectivity needs, and the ability to create your own connector to any REST API as well.
Yeah.
And you can see here that Maia's got an innate knowledge about all of the data pipeline language. So that's our IP, that's our code base that is creating these YAML files inside of the data productivity cloud. Maia is able to build pipelines that use the components, but it can also generate good code and assess existing code as well. So if you've got a big, beefy Python file, you can just upload that into your external Git repository, point Maia towards it, tell it, figure out what this code is doing, then convert it.
Maia is very polyglot, so it can speak Alteryx, it can speak Informatica, it can speak R-SQL or similar. It's also polyglot. It's perfectly fluent in French, German, Japanese. We've had users in multiple languages understand it, despite the fact we don't have a localized UI.
So, Nyan, are you using any tools at the moment today? You're using no tools. Okay, a perfect customer. Vendors, you'll be attacked as you leave this theatre. But we could go and create a fictitious Alteryx, Informatica, Talent. Even we've been working with Click as well to convert those quite beefy, complex code bases. Because we're using Bedrock and Frontier models under the hood, it has knowledge of all of those latest and greatest code bases that across your organizations today. So things like Python are really old, like, you know, IBM code languages and things like that, that you can then just point Maia towards, and it can translate into business intent. So you can say this set of pipelines are doing this, go and learn that intent from those pipelines, and then go and optimize and rebuild them inside of Maia, inside of the data productivity cloud.
It's really good at understanding your intent in old pipelines, stuff your colleagues built. If you got two that are mismatching and don't understand the results, you can ask Maia to compare the two pipelines and say, why am I getting different data from these? What's the differences? Equally, to look at a Git diff and then explain, okay, what practical change has been made here?
So what we can see here is we've got Maia's built our 3 connections to our Postgres. We could use a variable in an iterator. We could tell Maia, actually, you know, just loop through this one connection string and go and get me all of those tables if I wanted to make it a bit cleaner. But it's moved that data now into our Snowflake. And Maia is now building out our star schema model. So it is actually here inside of our transformation pipelines. It realizes that it doesn't have those tables in there yet. So it's actually asked me to go and run a pipeline. So it's now going and executing on that load from Postgres, moving that data into our Snowflake. And then it's going to come back and it's going to say, right, great, we've got our data loaded. Let's go on and start building out that star schema model. Now, whilst it starts doing this, I'm going to just showcase one element of connectivity. So hands up if you spend a lot of time building connectors to REST API sources or trying to load data in. Yep, there we go. Got a few hands there. Yep. Fantastic. Maia can also help with connectivity to hard to reach REST APIs as well. So here you can see we've got a public facing documentation of a REST API with some fictitious, endpoints. Yeah. And we can come here into Maia and I can say to Maia, well, actually, I'd like you to build me a connector from scratch just by reading those endpoints. So I'm going to put Maia to work here on building that connector. It's going to go away, scour through the web pages of those docs. And now I've got a couple of endpoints that I can bring back in here. Going to import that across. And apologies, you're going to see my very messy secret manager.
Yeah, for the completely fictitious specific weather data I created a few months ago. But
you're going to see my secret manager, which is just, in fact, a sticky note.
Yeah.
Yeah,
that is the one piece that
highly
obviously
sophisticated.
You don't want to pass your secret directly through Maia. So
now I have my now I've got my API key in here. Maia can now go and test, sample, build that connection, and it's brought us back a sample here at the bottom of what that data looks like. So now we've built a connector to a data source in under 30 seconds. We could then go ahead and use this connector to ingest into our Snowflake, Databricks, or Redshift. Now I come back here to see how Maia's getting on. The Wi-Fi is a little poor. We're going to just wait for that one to catch up. And we can then also use Maia to help troubleshoot existing pipelines. So when you've got all of your pipelines running in production, you can set them to schedule or you can have them triggered. And then Maia can also read the logs from those CloudWatch analytics. So you're running it in Elastic Container Service. You're getting these detailed logs about why a particular pipeline failed. You can then point Maia towards those logs, and Maia can then read your logs and tell you, you had an unexpected item in your SQL syntax. Here is the recommended fix. Now go and actually take that recommendation, go find that pipeline, and update that fix. So Maia's not only helping at that building stage, but it's also helping with the maintenance of those existing and scheduled pipelines. So we're coming back here. We've now got our tables loaded in, and we're in a transformation pipeline. So we're going to be, this is all executing inside of our Snowflake warehouse. So it's creating SnowSQL, and it's going to use our components. And you can see there, it's just starting to create that star schema model. As it goes through, it's generating SQL that's going to be executed inside of Snowflake, using Snowflake, Redshift, or Databricks specific SQL. And it's testing as it goes. So we've got those nice.
It gets feedback. You may see it go red. You saw it go red there on one of the components, and you might have noticed a comment saying, "Oh, I need to correct that component." So it gets the most obvious validations. It then carries on with the updates based on the error message. No different. Somebody vibe coding. You try the code, you get an error, you pass it back to ChatGPT. We don't have that loop. Maia gets the feedback. So that's part of what's the key to enabling Maia to give it such complex instructions that it can work away on. It's not coming back to the user every 10 seconds. That's enabling you to work in the style Joe's doing here, where he's got 3 tabs going on 3 completely parallel tasks all at the same time.
So Maya's finished building its star schema model. It's got the facts and dimension tables at the end. It's really good at building data vaults as well. Hands up for data vault fans. Just one, yes. Champion. Right, it's really good at building data vaults too. And after it's built these pipelines, we can actually ask Maya to explain what it's done. So I can select these components where we've got some calculations, and I'm going to ask Maya to document this pipeline as well. So it's adding natural language summary of these components on the canvas so that when Julian or Cyril check this project back in later, they can actually get a human readable summary of what these calculations are doing, why it did that.
It's a good sanity check that you've built what you thought you were building.
So now we're building Nine's predictive model. So next quarter, you're going to have some new targets. We're going to see what Maya's come up with here. It's built us out a Q4 revenue forecast and a revenue summary dashboard. And it's used some calculations here to calculate the growth trends. So you can actually inspect and see, based on the consultant skill level here, whether or not there's going to be a difference in projected revenue growth and across the different industries that Squawk will work with as well. So we can inspect and see the SQL. If we don't like the calculations, Maya's here available. You can just prompt it, actually just use a case statement for this or change it to do something else. So Maya's now fully built out our revenue prediction model. It's going to create a summary of its work, and it's going to create the documentation for us as well. So we've got a README file. We can add the facts and dimensions models to our data landscape so that when we're building in the future, we can use that again, and we can walk through our deployment. So our CI/CD, push it out to our external remote repository, and then go and perform any code checks that we want on there as well. So you can see here it's creating that analytics documentation markdown file. I'll show you what that looks like in just a second.
There's a lot of power potential we see there for Maya to document as it goes. And we're starting our next generation tools that involve asking Maya to reflect on what it's learned about the data landscape and update its context and update its semantic memory based on the user interaction. So keeping it far more up to date than any written wiki or similar.
So just whilst we're waiting on Maya to finish its documentation, it's then also going to bring us back with some summary of its work and also summary of its findings based on the data that was available. Now, if you wanted to also add in additional data sources into the model, you could then continue building and prompting Maya to do that. If you wanted to convert your existing pipeline estate, like it's all in Python at the moment, you can have all your Python files, perform the conversion, and you can ask Maya to help optimize that code base as well. Yeah. So crucially, Maya can consult with you as a human data engineer, and you then become wildly more productive when building and using Maya for your data engineering needs.
Those context files might not just be data schemas, but it could be design standards, coding standards, best practice guidelines that you maybe your senior lead wants to establish for the whole team, and then it becomes comments that are enforced on the behavior of everybody across the team, across the project.
So you can see it's built our documentation for this particular project, the architecture overview, the data quality and validation checks. It's even included the predictive analytics model here as well. And it's summarized all of that for us here inside of Maya. So you're looking at a 15% growth for Q4. So the data went up to 2024. There we go. So it's predicted for Q4 of 24, and then it's also got some recommendations here and insights that it uncovered as part of that. Now you could then take that further. We're starting to work with teams that are putting Maya in the hands of their business analysts, in the hands of their data analysts across those different lines of business that are wanting to build and self-serve the pipelines and answers that they're currently maybe doing elsewhere, but they want to do that in a way that conforms with the data engineering best practices and standards of your organization. And so that's why these context files are so critical and crucial to get right. And these you can build all of these with Maya as well. You can consult with Maya on how to build star schemas and data vaults that fit your different naming conventions or quality checks. And Maya can then adhere to and read from these rules as it builds out pipelines for your line of business analysts and engineers.
And as it's building all those out, of course, it's creating pipelines. So you can check its workings for any analysis that comes out. You can check back and edit them. You can review how it calculated them. It's not like I've just asked a model to splurge off on its own and come up with any report.
And then last but not least, now we're ready to push this into production. We can commit our changes. Maia, again, is going to help generate that commit message. So it's going to read through this local session, summarize what we've done, provide a nice detailed commit message here. I can commit that here locally. We support Azure DevOps, GitHub, GitLab, Bitbucket as well. There's always one that fails to escape me. And I can push these from my local repository out to my remote repository.
Yeah.
So then I can have all of my YAML files available in that external Git location, as well as other code files that I might want to use in there as well. I can
probably
browse
want to
through
build
here.
that in dev and then push it up to prod when you're ready.
And I can browse through my Python SQL files here. I can visually see that high code if I want to here in the canvas. And if I'm in a my low code environment, I can also actually check and see the SQL that's being generated as we built out. And I can see here, once it's validated, here is the 80 odd lines of SQL that was created by Maia to build this particular facts and dimensions table. So full visibility in a low code, no code platform. Thank you very much.
Oh.
Just been told we don't have too long left, and we do want to pause for some questions. My first question to Nyan: did this beat, and exceed your expectations?
Yeah, look great.
Fantastic. So months of work into 10 minutes.
Yeah.
Fair surmises. Fantastic. That's great to hear. We are available at the booth.
Yeah. So you're gonna put the.
We're available at the booth 50 over there if you'd like to see more detailed demo. And we've got some time for some
Time for any
questions from the
questions?
audience if people would like to ask. Any questions from the team?
One over there.
One over there.
Yeah. Yeah.
Did you build your own agentic framework underneath, or did you use an?
Yeah, we
built
found
your own?
LangFuse 2 constrictive and LangChain 2 constrictive on us, so we built our own frame. Also, partly because we started our first experiments building this would start about 2 years ago, so there wasn't as much in the way of tools available at that point.
Thank you.
Cool. Any more? I think everyone's lots of finding out. Alternatively, come find us at the booth if you want to grab us in person. Thank you very much for your time and attention, everybody.
Thank you.